So we'll move on to the first problem of mechanical translational systems. So we have been given a diagram here, and we will be asked to find the transfer function. So here determine the transfer function y2 of s by f of s of the system. So this is the diagram given. Based on this diagram we have to follow. So here it is in vertical direction, the entire object is, so the displacements are given in terms of y. So basically the displacement will be given in terms of x, since it was considered as an horizontal. Here it is vertical, so the displacement is mentioned as y. So I will consider the first displacement as y1 and the second displacement as y2, and the applied force f of t is given on the object m1. So here the object which is termed as m1 is the mass of the object, k1 is the elasticity, b is the frictional element, k2 is the elasticity between m1 and m2 is the mass of the second element. So here we are supposed to know the Laplace transform. So Laplace transform of f of t is Laplace transform of f of t equal to f of s, that is capital F of s. Similarly, Laplace transform of y1 of t equal to capital Y1 of s. Similarly, Laplace transform of small y2 of t equal to capital Y2 of s. These are the basics thing. So you are going to consider each and every element. I am going to consider the first element, which is m1. So I am writing and drawing the left corner. You can see the free body diagram of that element m1. When you are going to see the actual diagram, so what are the opposing forces this m1 comes into? It has been connected to a k1, and it has been connected to a frictional element b, and it has been connected to an elastic element k2. So it has three opposing forces and one more opposing force based on the mass m1. So it has four opposing forces and an applied force f of t. So when the free body diagram is given, all the opposing forces should be inward direction. So inward direction fm1, fb, fk1 and fk2, and the outward direction is the applied force f of t. By using this idealized formulations, we can write the equations for fm1, fb, fk1 and fk2 directly. So fm1 equal to m1 into d square y1 by dt square, fb is equal to b into dy1 by dt, fk1 equal to k1 into y1, fk2 equal to k2 into y1 minus y2. Here you take a look at k2 is placed between two displacements. Since we are taking the object to be primarily in the displacement y1, so here the fk2 value will be y1 minus y2. If you are going to consider the second element m2, it will be something like y2 minus y1. Since it is considered for the first element, it is y1 minus y2. So by Newton's second law, we can add all those opposing forces. The opposing forces, summation of opposing forces will be equal to the applied force. So it is fm1 plus fb plus fk1 plus fk2 equal to f of t. So we will substitute all those terminologies here. For further simplification, we have to do Laplace transform. So when you are going to do Laplace transform for a differentiation, it's going to be Laplace transform for dy of dt is equal to s into y of t. Each and every differentiation you will have an s term. If the degree of differentiation increases, the power of s increases. So if it is going to be d square y of dt square, it's going to be s square into y of s. If it is d cube y of d cube y by dt square, it's going to be s cube into y of t. So when the degree of differentiation increases, the power of s also increases. So we are writing the equation here and applying Laplace transform on both sides. So when you are going to apply Laplace transform for the first term, that is m1 d square y1 by dt square, the answer will be m1 into s square into capital Y1 of s. Similarly, when you are going for the second term, that is b into dy1 by dt, it will be b into s into y1 of s. The s represents single differentiation. In the previous term, s square shows that it is double differentiation. We will move on to the third term, that is k1 y1, which is done Laplace transform, so it is k1 into capital Y1 of s. So when you are doing it for the last term, that is k2 y1 minus y2, that is k2 y1 of s minus k2 y2 of s equal to f of s. So we have done the Laplace transform, and you have to remember our objective is to find the value of capital Y2 of s by f of s. So here what I will do is, I will take all those common term of y1 of s and common term of y2 of s, and I will form an equation and I will mark it as equation number A. That's what we have done, and we will move on to the second object. Second object is m2. So what are the components that get connected with m2? Only the elastic component k2. So the equations will be somewhat simpler, and we can get the Laplace transform much easier than the previous term. So when you are going to draw the free body diagram of m2, the opposing forces are Fm2 and Fk2, and we do not have any applied force in second object. So when you are going to apply Newton's second law, that is Fm2 plus Fk2 equal to 0, Fm2 is equal to m2 into d square y2 by dt square. Here the displacement is y2, so it is termed as d square y2 by dt square. Fk2, as I explained already, this k2 is present between m1 and m2. Since we are seeing m1 as the primary component, here the answer will be k2 into y2 minus y1. In the previous case we have termed as y1 minus y2, here it is y2 minus y1. So when you are going to do it according to Newton's second law, I will write it as m2 d square y2 by dt square plus k2 into y2 minus y1 equal to 0. After applying Laplace transform based on the degree of differentiation, we will get the power of s. So it is m2 s square y2 of s plus k2 into y2 of s minus k2 into y1 of s equal to 0. So we will take y1 equal to y2 of s into m2 s square plus k2 by k2. Why we are doing this is, our objective is to get the value of y2 of s by f of s. So we have to eliminate y1. So by using this equation, I will get the value of y1 of s, and I will mark this as equation number b, and we will substitute this value in equation number a such that the entire y1 of s will get eliminated. So I am taking this as equation number b, and I will substitute this b in a. So the entire y1 of s is completely eliminated, and here the terms are based on y2 of s, and we have the right hand side is f of s. So I will take the common y2 of s, and our objective is to get only y2 of s by f of s. Now we will do some cross multiplication. The right hand side f of s will come to the left hand side denominator, and this entire term which is in the square bracket will move to the right side. So the denominator moves to the numerator, and the numerator becomes denominator. We got the answer now. So the entire answer for the first problem is been obtained. So if you like this mechanical translation problem video, kindly share it with your friends, and subscribe the channel, and click the bell icon to get constant updates. Thank you.